Hello, Algebra 2 folks, and welcome to Unit 2, Linear Functions. And today we are going to be graphing linear functions. We're going to be graphing them using x and y intercepts and the translated form. All right, so you need your notebook, a calculator, and pen and pencil, and about 4 pieces of graph paper. Okay, so let's get started. So the learning targets for today, and yes, you need to write these down again, are I can determine the x and y intercepts of a linear function. I can graph a linear function using those x and y intercepts. And finally, I can graph a linear function using the translations of y equals x. So we got a lot to learn today. All right, so let's just take it back a minute and remember what we did yesterday. And we found the slope and the y-intercept, and we graphed using slope and y-intercept. So the slope is the m, and that in this case is 6. And the y-intercept is 0, 5. All right, and we would go and start with the intercept 0, 5, and this is 10, so these must be going by 2. So 2, 4, 5 is right here. We make a point at 0, 5, and then we would use our slope of 6 over 1, rise up 6, run over 1. So 1, 2 is in the middle, 3, 4, 5, 6 over 1. 6 over 1 would be right there, or we could go down 6, negative 6, and then left 1. Okay, and then we would sketch a nice line between all the points, and that would be our graph. Okay, so that's what we've done. All right, so now what if the equation is not in y equals mx plus b form? Well, now we have a problem because everybody thinks, well, we got to get it into y equals mx plus b form, but we don't. We don't have to rewrite the equation in that form. There is an easier way to graph. So instead of taking this equation and solving for y, this is a literal equation. You could solve for y. I'm not saying that you can't, but there is an easier way to graph when it is in this standard form. And that is by using x and y intercepts. Okay? So what does that look like? What does the graph look like if we have x and y intercepts? Well, looking at a graph, the x and y intercepts are where it crosses the x-axis and the y-axis. So this is your x-intercept, which is ordered pair 6, 0. And this point is 0, -4, and this is your y-intercept. So your y-intercept is on your y-axis, your x-intercept is on your x-intercept, and x-axis, excuse me. And what do these points have in common? Well, they both have a 0, okay? They both have a 0 in common, and that's really important. So ways to quick sketch a graph of a line would be using the y equals mx plus b. But using intercepts, we would find the x-intercept of the equation, which is the point where the graph crosses the x-axis. And to find that, you would make y 0. So let's do that over here. Let's make y 0. Okay, and you would solve for x. So 3x plus 0 equals 4, 3x equals 4, divide by 3, x equals 4 over 3. So the x-intercept would be in this case, 4 over 3 comma 0. And you would plot that a little bit over 1 1⅓. Okay, now to find the y-intercept of that same graph, you would take the equation, and the y-intercept is the point where the graph crosses the y-axis. So you would plug in x equals 0. So everywhere you see an x, you plug in a 0. That would make 0. You'd have 2y equals 4. You divide by 2, and y would equal 2. And so the y-intercept of that graph would be 0, 2. Okay? They don't allow you to write the x-intercept in x equals form because that could look like a line. You have to write it in ordered pair form. Okay? So make sure that your x and y intercepts are in ordered pair form. Now you would plot both of those points on a graph and you'd connect the line. And you would have your quick sketch of your graph. Okay? So let's try a couple and graph them at the same time. So hopefully you have this example down with the x and y intercepts, and then now we're going to do it where we find the x and y intercepts and we also graph them. Okay, so example number 1. Find the x and y intercepts of the equation and then quick sketch it. Okay, so the first thing I'm going to do is find my x-intercept. Okay, so I plug 0, oops, I needed a plus sign there, sorry. I plug 0 in for y. So when you want the x-intercept, you got to make y equals 0. So 5x equals 20. Divide both sides by 5, and you get x equals 4. So therefore, the x-intercept is 4, 0. Okay. Now we need the y-intercept. That's where we put x equals 0. So 5 times 0 plus 2y equals 20. 5 times 0 is 0, so we have 2y equals 20, y equals 10. Therefore, this little triangle with 3 dots means therefore. Therefore, the intercept would be 0, 10. So you would go to 4, 0 on the x-intercept, 4, 0, 2, 4, 0. And you'd go to 0, 10, that's the y. You'd plot a point, and you would make, oops, you'd make a quick sketch of these 2 points. You'd make a straight line. Please use a ruler. It's not something I am able to do with what I have in front of me for my tablet. But I expect them to be nice and straight. Sorry, mine's not nice and straight. Okay, so we have x-intercept, y-intercept, and we've got a quick sketch. So let's do it again. So let's find the x-intercept where y is plugged in as 0. So 4 times 0 is 0. I would add 9 to both sides. 9 equals 3x. Divide by 3, and x equals 3. So therefore, the x-intercept is 3, 0. Now we'll plug in and find the y-intercept where x is equal to 0. And 4y equals -9, y equals -9/4, which is about -2 1/4. So therefore, the y-intercept is 0, -2 1/4. All right, so we go to the x-axis and we go 3, 0. We go to the y-axis and we go down 2 and a little bit more. And we take a ruler and we sketch a quick sketch where we put a line in between those 2 points with arrows on both sides. So again, please use a ruler or a straight edge. It doesn't have to be a ruler, but it can be a straight edge like your your notebook, or even your tablet or something like that can allow you to give you that straight line. So we found the x-intercepts, the y-intercept, and we did a quick sketch. Okay, so what if the equation isn't in y equals mx plus b, or in an easy form to find intercepts? Well, if it's not in either one of those, will you have to rewrite the equation in one of those forms, or is there an easier way? Well, let me tell you, there's always an easier way, okay? So if we had y equals 2 times x minus 3 plus 4, we could distribute that 2 and get it into y equals mx plus b. But we can also use that as a way of graphing, okay? So you don't have to do anything with that graph. I'm going to show you how you would find the graph of that equation quickly. So we already know how to use slope-intercept. We already know how to do the intercepts, x and y intercepts. But now we're going to use translations. So translations is when we have what appears to be an h and a k. So we have m, we have slope, okay? And we're going to use slope to find our second point. But our first point that we're going to plot is h and k. So this is the horizontal shift. Take the opposite of h and you'll get h. Opposite of negative h is h. And then take your k and bring it down, and you have an ordered pair. And you can start with this point. And then once you plot that point and you use your m to find that second point, you can connect the lines and graph. Okay, so I know this is a new thing for you and you've never seen it before, but it is amazing. And later on in Algebra 2, we use horizontal and vertical shifts for the rest of the year. And our K is the vertical shift, so I better write that down. It's how much it goes up or down, and this is how much it goes left or right. And we use this in absolute values. We use it in quadratics. We use it in cubics. We use it in square roots. We use it in polynomials. We use this in all forms of graphing for the rest of the year. So if we can get this down today, you are going to be set for the year. So let's do an example, okay? So we know the 2 is our slope. And then this is our h and our k. But remember, we need to do opposite of h. So opposite of negative 3 would be 3. And then we take whatever k is, 4. Plot that point, 3, 4. So 3 is the x. This is by 2. So 2, 3. This is 3. And then go up 4, 2, 4. Make a point. Now use your slope. Up 2 over 1, up 2 over 1, up 2 over 1. And draw your line. Quick and easy. No distributive property. No accidentally making mistakes with negatives. You have your point, you have your slope, and bam, you have your equation graphed. Okay? Let's try it one more time. Slope. Opposite of 1 would be negative 1, and negative 2 we would bring just down. So opposite of what's inside the parentheses, and then just bring down your k. This is your h, this is your k, this is your random point. So negative 1, negative 2, make a point. Then use your slope. Down 2, right 3, make a point. There's your line. Okay? So, in the near future, we're going to find x and y intercepts when x is being squared. Okay, that's coming soon. But for right now, let's take a look at the summary. So you can graph when you have a slope and a point where your point is the y-intercept. You use your point, your intercept, you use your slope, you connect the lines. That's one way to graph. Second way to graph that we learned today is the intercepts. So when your form is in this standard form and you don't want to solve for y, you plug x in, you plug 0 in for y and you find your x-intercept, plug 0 in for the x and find your y-intercept. 0, zeros, nice. Plot those points on your x and y axes and connect the line. And then the third way, if it's in this translated form, okay, so it means it's moving or shifting left or right, up or down. You figure out what your h and k is. Remember, h in the parentheses is opposite. And then you bring down your k, plot that point, use your slope to find another line or another point for the line, and then connect the points. So 3 ways to graph where you don't have to solve for y. You don't have to manipulate the equation. Look at the equations and find the easiest way to graph the line and go with it. Okay, that's all I have for you today. This is Brendan signing off. Peace out. We'll see you tomorrow.